Good morning, students. So, in the yesterday's class, we already studied the reactions, the preparations, the chemical properties of alloalkanes, allorenes, alcohols, phenols, and ketones, halides, ketones, and carboxylic acid, and also amides. So, in the before, I already explained. So, an important question, nomenclature is important as well as classification is also important. There may be a chance of rising 1 marks question among these two. So I choose all these nomenclature at a time. Means all the 4 chapters, both alloalkane, allorane, alcohol, phenol, halide, ketone, amines. Together I will explain the nomenclature. If which functional group is present, how to name that compound. Okay, but at the same time classification also in that types are there, like whatever it is, primary is there, secondary is there, tertiary is there, allylic is there. Like the classifications are there. That is also I will explain. Understand? So listen. So we will go over nomenclature of organic compounds. Okay. So students, in that we will discuss first one, alloalkanes and alloalides. Okay, nomenclature. So here I write the structure. Here I will discuss only IUPAC, International Union of Pure and Applied Chemistry. IUPAC name or IUPAC name. I will only discuss that because they will ask only IUPAC. So students, initially start with a simple compound, that is okay, I think. So structure, the name follows here. Alloalkane. For what? Aliphatic structures or aliphatic compounds. So I'll go with the first one, that is CH3Cl. Of course, this is a aliphatic group, means alkyl group. So benzene ring is there, then that is aromatic. So if aliphatic group is there, we are taking that CH3Cl, a simple alloalkane. So students, the name allo is replaced by halogen. The name alkane is replaced by this alkyl group. Okay? So listen, you already well known about that. If 1 carbon is there, that is meth. 2 carbon means eth. 3 carbon means pro. Similarly, bute, pent, okay, X, F, and you know that. Okay? So here CH3Cl is there. Cl means, of course, this is the halogen. Or often we are using 5 halogens: fluorine, chlorine, bromine, iodine. In the name of allo, there follows fluoro, chloro, bromo, iodine. Are you getting? So allo means halogen, means fluorine, chlorine, halides, fluorides, chlorides, bromides. Allo here. Allo means fluoro, chloro, bromo, and iodine. So here Cl atom is there. That's why it is chloro. And here carbon chain is having only 1 carbon atom, so that is methane. Why it is methane? Because this carbon is having only single bond. That's why here the functional group is only single bond, alkane. If double bond is there, that is alkene. Like later it is. So the next one, another one simple. CH3, CH2, Br. So students, here this is the functional group, this is the parent chain. So in the place of allo, which Br is there, means the name follows bromo. Okay, and here 2 carbon atoms are there, so that is ethane. Bromoethane is name of the compound. Remember, if this halogen atom, so here it is the functional group, halogen atom is the functional group here. But this halogen, even though it is a functional group, the priority is given to alkyl group rather than this halogen group. Are you getting? So that's why only it has prefix, not suffix. So these halogen compounds, nitro compounds, alkoxy compounds, they used as prefixes. They prefer in the form of a prefix rather than in the suffix. Okay, next. Third one. CH3, CH, CH3, CO. So students, if it is like that, remember, as I told you, importance is given to the alkyl group rather than this halogen. And the main thing is the selection of the parent chain. If we need to name any one of the compound, main thing is the selection of the parent chain. What is that parent chain? A continuous chain of a carbon atom. So there is no, I'm not telling it must be a straight chain or it must be like this. So the straight chain must be any of them. Okay, it may be any other. I'm not telling any about shape. It must be a continuous chain of carbon atom. Don't worry about the structure because as I told you, so if we consider this one as a parent chain, as the Cl atom is attached, so this CH3 is left. Among halogen and alkyl group, the preference is given to alkyl group. And at the same time, so instead of considering this straight chain as a parent chain, if we consider this one, then this parent chain consists of 3 carbon atoms. Here in the straight chain, only 2 carbon atoms. In this chain, it is 3 carbon atoms. Of course, then this is the correct way of selecting the parent chain. Okay, then don't worry about the position of the halogen. Okay, once you got the parent chain, start from below, either from left to right or right to left, any one of them. But here, students, remember 1, 2, 3 is there. Either from this side you do, there is 1, 2, 3. At the second position only, this halogen is there. So no matter whichever the way you choose, the compound remains same. So in the next example, I will show how to choose the position. So listen, this is 1, 2, 3 carbon atom with the second position halogen. So right here, the position of halogen first, 2 chloro. Okay, 2 chloro and the parent chain is propane. Students, remember here, while writing the number and the name, so we have to separate them by hyphen. So if we want to write the continuously number, they are separated by commas. So the numbers are separated by commas, number and name is separated by hyphen. Remember that. Always you need to you need to follow the IU patterns. So the next one. I'll select the straight chain only. So students, note down here, this is the parent chain. So if this is the parent chain, I'll just write this. Okay, listen, if this is the parent chain, there is two ways of numbering the parent chain. One is left, another one is right. So listen here, when we numbering from left to right, this is 1, 2, 3. And right to left, this is 1, 2, 3, 4. So students, when this type of compound is there, then we need to check the position of the Cl atom. If we number the compound from left to right, this carbon atom which is bonded to this Cl is getting third position. Okay, when we numbering from right to left, this carbon is assigning with what? Number 2. So then the main thing we need to consider is we need to check the smaller value. Among 3 and among 4, 2 is the smaller value. So according to such a way, we need to number the parent chain in such a way these substituted atom should get the minimum value. So if we number from left to right, it is getting 3 value, right to left, it is getting 2 value. So right to left is the correct way of numbering. So then simply write at the second position Cl atom is there. So that is again 2 chloro, 15, 2 chloro, butane. Okay? So the next one. Okay? Here. So in the place of Bihar, you may take ions. Okay, you take ions. I'm not telling only chloride is present, bromide is present, iodide is present. You may choose any ion. And remember, fluorine is somewhat less reactive than this. Means fluorine compounds are less known because of the high reactivity of the fluorine and the smaller size of the fluorine. But this chlorine, bromine, iodide compounds are vast in our universe. Okay, fluorine compounds are less in quantity. So next here, if you consider as I told you. So here halogens are there and 3 carbon atoms are there, and sorry, this carbon atom is bonded to 3 carbon atom and 1 iodine. So here students, there is 2 possibilities of selecting the parent chain. So one is in a straight chain. Okay, so when we select in a straight chain, we are getting 2 carbon atoms here. So instead of that, so if you select this one as a parent chain, then we are getting 3 carbon atoms. Then the correct way of selecting the parent chain is this one. Then start numbering. Of course, they are exactly at the middle means start numbering from any one of the side. That is correct. So 1, 2, 3. Now, here students, this is methyl, this is iodine, I and N. So if 2 substituents are there and they are at the same place, okay, and both are on prefixes. Prefixes means which they comes first than this root word. Listen, outer name the compound means initial followed by the root word. These prefixes are always substituted. This root word is a parent chain. This suffix is a functional group. This is the correct way of writing the nomenclature. So prefixes, root word, suffix. Prefixes are substituents. Root word is a parent chain. Suffix is a functional group. Okay, so here the substituent 2 are there. One is alkyl and the other one is iodine, as they are the prefixes. So listen, when 2 or more substituents are there, then the nomenclature follows another rule, means the substituents are named according to the alphabetical order. So this CH3 group is called as methyl group. So this group is called as iodine group. So in the alphabetical order, I comes first. So this is named first, means iodine. Position of iodine is 2. And next, 2-methyl. Okay, and this the parent chain is okay. Are you getting? And remember, while writing should be in capital, remaining are followed by the small letters only. But if in case mono, di, tri, like that type of compounds are there, all are considered in small letters only. So 2-iodine, 2-methyl propane. And remember, the main thing you have to remember is, so listen, methyl. Okay, so if we have to remove this L, sorry, last E, because CH4 is a methyl, CH3 is a methyl. Because one E, the last E is replaced by either any one of the prefix or a suffix, functional group like that. Okay, we cannot write last E in the nomenclature because this last E is replaced by this propane chain like that. Understand? Okay. So remember this order: prefix, root word, suffix. Okay, so this is all about alloalkanes. So if we consider alloalkane, okay, so no doubt it is chlorobenzene. So students, in this, if only one atoms are there, no need to write the positions. Why? So any one of the compounds, if this here is here, no doubt all the compound and all the carbon positions are same. So we cannot number the position of chlorine atom here. Are you getting? So chlorobenzene is the correct answer. If two groups are meta cannot be possible. Okay, so then this is the functional group 2, 3, 4, 5, 6. Then here two halogen atoms are there, that is dichloro. So the position of two halogen atom is 2, 1, 2. So dichloro benzene. So students, and also remember, if this is the functional group, these two are the ortho position. This one is the para position. These two are the meta position. So this halogen and this halogen is ortho to each other. Then it can be also written as ortho dichlorobenzene. This ortho is written as italic form. So instead of that, okay, here two halogen atoms are there. That is, you may write 1, 2, 3, 4 position. 1, 4 dichlorobenzene, or so these two are para to each other. So para dichlorobenzene, both are correct. Both are correct. And next, the ninth one. Listen here. Assume here both CH3 group is there attached here, as well as Cl atom is there. So students, as I told you, both the halogen is there as well as alkyl group is there. So the preference is given to the alkyl group, not to this halogen atom. Means here the most clear will be the substitute alkyl. Are you getting? So then the name of the compound follows here is. So listen, later I will say. So this is first carbon atom, second, third, fourth. 4-chloro benzene. Okay? So write 4-chloro methyl benzene. This is one. So students, remember, this benzene ring with the CH3 is called as toluene. Okay, and these two are para to each other. And also write para chlorotoluene. What is the main thing? So listen here, as it is alloalkane, in this is that is alloarene. Benzene. This follows this one chloro. If you take Br, that is bromo. Okay, so if you want to take, you can take here examples of by substituted compounds. So this is 1, 2, 3, 4, 5, 6. Okay. So the name of the compound is 1, 3, 5 tribromobenzene. Okay. Listen, bromobenzene is the name of the compound. So this bromobenzene, this bromine is 3 types. So 2 are there, only one is there, chloro, that is mono. If 2 are there, we use tri. Here 3 are there, so we use tri. If 4 are there, tetra, penta, hexa, like that. Okay, these are the prefixes. So this is all about the nomenclature of alloalkanes and allohalides. So students, still they didn't ask any question regarding this nomenclature of alloalkane and allohalide. But the thing is, they this year they reduced the syllabus. There may be a chance of raising the question in this topic also. But as I am explaining both the nomenclatures, I will explain each and everything. But from next chapter, that is alcohols, phenols, aldehydes, and amines, of course, they are often going to use a nomenclature for 1 mark. Okay? So the next one is nomenclature of alcohols. Initially, we study alcohols, later phenols, later ethers. Okay, so in this aliphatic structure, the name follows. Listen, alkane, alkane, or alkene, or alkyne. I'm not telling only alkane single bonded compounds. It may be alkane, or alkene, or alkyne. So this last E is replaced by OL. That is alkanol. This is the IUPAC name. Means for alcohols OH group, the suffix is OL. Okay, so if OH group is there, that is considered as a main group here, OH. As a functional group, it carries a suffix OL, ol. So if this is the parent chain alkane, the last is replaced by alcoholic group. Because why? Listen. So this is the methane, H, 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 H. This is methane. Okay, so all are single bond, that's why it is methane. But if one H is replaced by one OH, so one E is replaced by OL. If 2H is replaced by OH, then 1E is replaced by diol. If it is replaced by 3OH, then it is triol, like that. Okay, so means last E of the parent chain is replaced by the number of alcoholic groups. Okay, so we will discuss one by one here. So I'll continue with the simple one, CH3 OH. Just now I told you this. Only one OH group is there and the CH3 is there. How the CH3 in the form of alkane comes? That is methane. For one carbon atom, meth. For 4 single bonds, methane. As I told you, the last E is replaced by this alcoholic group, that is methanol. This is how to name the compound, methanol. So next, note here, 2 groups are there. So ethane, the last E is replaced by OL, that is ethanol. Next, so in the place of this ethanol, if 2 OH groups are there, okay, then of course this is the parent chain. What is ethane? Replaced by how many alcohol? 2 alcohols. That is diol. At first carbon atom and second carbon atom, alcohols are ethane. 1, 2, diol is the correct name. Ethane, 1, 2, diol. Next. Okay. So here 3 carbon atoms are there with 1 OH group, that is propanol. But if the compound is like this, CH3, CH, OH, CH3. So students now, so instead of considering this one as a parent chain, we are considering this one as a parent chain with the 3 carbon atoms. That is propan 2 R. Both the compounds are propanol only. What is the difference? Here the OH group is at the first position, here the OH group is at the second position. CH3, CHOH, CH3. This is at what? Second position. This both are propanol only. But this property is different. This property is different. These two are the position isomers. And listen here. So here one position is there, no need to write the position number. But here we need to write the position. If we simply write both propanol and propanol, both remain same. There is no difference in between them. So that's why we are writing the positions here. In one place 1 is there, no need to write. If place 2 is there, we need to write. If 2 are simultaneously present like this, then your first and second position are mandatory to write. Okay? So the next. CH2OH. Next. CHOH. CH2OH. Note of students here. This is the parent chain and 3 OH groups are there. Means that is propan. The last is how many alcohols? 3. That is triol. And the position here is 1, 2, 3. So you simply write 1, 2, 3 triol. So propane triol is the name. 1, 2, 3 are the positions where the OH groups are present. Okay? So the next. Okay? So you have noted straight chain is the, of course this is butanol. Same if you consider okay. Listen students here. There is possibility of selecting 2 parent chains. One is this one, straight chain. Another one is this one. Okay. So here CH3 is among these two, if we consider the parent chain. So listen, here it is along with the alkyl group like CH2OH. So here this is not taken as a prior group. If we consider this parent chain, the substituent is CH2OH. Okay, so listen, if it is like this, CH3, CH2, of course this OH is assigning a particular position in the parent. But here it is not assigning exactly the particular position if we choose this parent chain. CH2 is also in this alkyl group. So this one is selected as a parent chain. Are you getting? So now it is the numbering also done from this side. 1, as I told you, the position importance is given to OH group. So the 1, 2 and 3 carbon atom, second carbon atom, methyl group is there. This is the functional group, this is the substituent. Then write the substituent first because it is first. That is 2-methyl propanol. 2-methyl propanol. Next, same CH3, C, CH3, CH3. So listen, if it is like this, if we consider only this straight chain, it is consisting of a 2 carbon atom with OH group. Of course, the OH group is named as a prior group here because it is getting a particular position. It's not like that. After CH2, not OH is here. If you consider it is not like that. Directly it is bonded to the carbon atom in a parent chain. It is assigning a proper position. So CH3, CH2 having 2 atom, this one. CH3, CH3 having 3 carbon atom. So then this is the way of selecting the parent chain. Then start numbering from above to below, below to above, both are same. So 1, 2, 3. At the second position, methyl group is there. So this is 2-methyl propanol. Propan, 2-ol. So listen, both the compounds are same. Methyl propanol, methyl propanol. Especially 2-methyl propanol, 2-methyl propanol. But what is the difference here? Here the OH group is at the first position and OH group is at the second position. So that's why I'm telling why I'm writing this much of different compounds means listen here. The main thing is the writing the position of the actual position of the functional groups. If you won't write it, you cannot easily distinguish the structures. You simply write the propanol, of course. So this is 2-methyl propanol, I told you. Propanol means it must be a CH3, CH2, OH, CH2, OH. This is also a propanol. Are you getting it? So each and every positions are very, very important to mention. So this is all about alcohols. So next. Okay. So if it is like this, so students double bond is there and OH group is there. So I'll write the priority order first. So listen, single bond, double bond, triple bond. Single bond, double bond, triple bond, and also sorry. First most prior group is COOH. Next COO, CONH2, CO, CN. Next CH4, next C double bond O, next NH2. Okay, next double bond, single triple bond. Next is double bond. Reference and next followed by alcohol, that is OH group. Okay, followed by alkyl group. Next halogens, next nitro group, next alkoxy. This is the R. Means if all the functional groups are present in the same compound, here double bond is there, alcohol is there. So double bond is here, alcohol is there. So preference is given to double bond. If COOH is there, double bond is there, then the preference is given to COOH. This is the order of priority of the functional group. So here in our carboxylic acid, ester, amide, cyanide, aldehyde, ketone, okay, alkyl, alorine, amine, as well as this. Okay, so those are the most prior groups. So CH3, CH double bond, CH, CH2, CH2. So the numbering, this is the parent chain, no doubt. So if you start numbering from here 1, 2, 3, 4, 5, and 1, 2, 3, 4. So students remember here. The preference is given to what? Double bond. Means, so from if we write number the compound from right to left, this is getting the position 3 for the carbon atom having double bond. If we start numbering from left to right, it is getting the position 2 where the double bond is present. So this is the correct way of numbering. Okay, so then here the parent chain is pentene because one double bond is there. So pentene. What is the position of the double bond? 2. So pent 2 ene. Wait. Pent 2 ene. Means pentene is the compound or a parent chain. The position of the pentene is 2. Okay, so the last E, because as I told you, if it is alkane, alkene or alkyne, the last E is replaced by this alcohol. So pentanol is the compound, but the position of the double bond is 2. So consider the same compound here, like CH3, CH, double bond CH, CHOH, CH3. So if it is like that, the same numbering start from here 1, 2, 3, 4, 5. Okay, so here pentene, the second position double bond is there, pentene is there. So this E is replaced by OL, but the position of that OL is 4. Means, wait a second, pent 2E 4 all. Pentanol is the compound. Here the OH group is at, sorry, position 5 all. Here it is 4. Okay, so this is about the nomenclature of aliphatic compounds. So now we will go to aromatic. Next one is aromatic. Okay. So students, in this aromatic structure, of course, the benzene with OH group is called as phenol. Benzenol. But that benzenol, another name is phenol. Okay? So the next one is, if it has a substituted product. So here, 1, 2, 3. Okay? So here it is 3-methyl, no doubt in this, phenol. 3-methyl phenol. Next. Okay, so listen, if two atom means two OH groups are there, then the name follows. Instead of phenol, it carries benzenol, means the position is 1, 3, benzene, the last is replaced by benzene triol. You may write the position here or here, nothing will affect because benzene ring is a cyclic ring. The position remains same. But in the aliphatic compound, it is not like that. The positions are different because it is an open chain structure. But here the positions are fixed. That's why you may write the number here. Like you may write benzene 1,3-diol or 1,3-benzene diol. Both are okay. So then next one. It is like this. Okay. So this is first position, second, third, fourth. How many alcohol group are there? 3. So that is 1 comma 3 comma 1 comma 2 comma 4. Benzene diol. Okay, this is the name of the compound. So if you consider this, so instead of that group, if any substituents are there. So here, this is the first, second, third, fourth, fifth, sixth position. Okay, then this is 2 comma 4 comma 6 tribromo, and this benzene ring with the OH is the parent child, that is phenol. So instead of that, if you take okay, this is 2 comma 4 comma 6 trinitrophenol. Are you getting? So this is also called as picric acid. Are you getting, students? So means in the aromatic compound, the nomenclature process is very easy compared with the aliphatic compounds because they simply consist of a one benzene ring. Of course, to that OH is attached. That is what phenol. It is called as phenol. Consider whether the substituted group, whether it is prior than this OH or less prior than this OH, most prior or less prior. Means, if listen, if I am considering this compound, here OH is there, here COOH is there. Then what happens? This COOH is the prior group. So instead of phenol, we are considering this as a benzoic acid because this is the prior group rather than this. Are you getting? This is the need of priority. But here I am taking halogen and the nitro groups. Both are less prior than the OH group. That's why they considered as a prefix. But among these COOH and OH, COOH is a prior group. Okay, so this is considered as benzoic acid. Means 2-hydroxy benzoic acid. So this type of compound and then nomenclature I'll explain in carboxylic acid nomenclature type. Okay, at that time I'll explain this type of compounds. Just remember what is the priority, what happens, and this is all about the phenol. Okay, in the next class we will discuss with the next compounds. Thank you.